Alright, so it's time to start talking about specifics when it comes to light and mirrors and so on. So we're going to talk first about reflection. Future videos will talk about refraction and some other things related to that. But we're going to start with reflection. So you can see a couple of pictures here where reflection is occurring. Pretty good quality mirrors, and these are cute images. So, well, kind of cute. This is cute. This is just kind of maybe cool image. But anyway, so this guy's leaning up against a mirror, and obviously you can tell it's not his cousin or something that's leaning against him. It's just his reflection in the mirror. And what the appearance of the reflection is going to vary slightly based on the angle that you're looking at the mirror and the angle that he is compared to the mirror. Same thing with the cat, right? You can only see part of the cat. If you stood at a different angle, or if the cat was in a different spot, you'd be able to see different parts of the cat in the mirror. Alright, so basically the question is, obviously there's no guy there, right? And there's no cat there. So why can you see them? Alright, well, several things are at work in basically deciding what we can see, why we can see it, especially when it comes to mirrors. Right? So, several things. First, the viewing angle. So it matters what angle you're standing at. Where the observer, that's you, stands is important. Now we've got several pictures here. I'm going to zoom in on these, and then we'll talk about this part. So just really quick, this is X, Y, Z. X can see the light ray, the laser beam. Sorry, X cannot see it. Y can see it, Z cannot see it. So let's see why that is. So zoom in here. Alright, so here we've got observer X, right? You'll notice this is a laser light beam, so it's a very tight beam. It does not spread out all over the place. So you have to be at the right place in order to see it directly. Now obviously we can see it because parts of it are reflecting off of the surface here. It's a rough surface, so parts of the beam reflect off of that surface and into our eye, but let's just suppose that this beam were in air and not on the surface of a desk or paper. Alright, so if this beam is in air and it's bouncing off of a mirror, then notice X is not at the proper angle compared to the angle that this is pointed, right? Angle of incidence equals angle of reflection. You can see where it's going, right? And it's not going toward observer X, so observer X would not see it. Same thing with observer Z. Wrong angle. He would not see it, or she. So observer Y is the only one of these three that would be able to see that reflected laser light beam, and of course that probably would not be very good for observer Y's eyes, because laser light is not good to have directly in your eyes. But in any case, this is the person who would see it, not this one, not that one. Okay, so this slide just has a few more points without pictures, so we'll just kind of go through this. You can only see light rays that actually enter your eye. Now obviously this is a restatement of the previous point. Where you stand matters, your viewpoint matters. You can only see light rays if they enter your eye. If they don't enter your eye, you can't see them. That's really kind of obvious, but it's important to remember. Alright, second thing, your eye cannot tell. Like, you can't tell light that's reflected from light that hasn't reflected. I mean, all light is really the same. Alright, the light doesn't tell you if the light has reflected or not. You have to interpret based on what you can see whether there's a reflection going on there. And sometimes you're wrong and you're totally fooled because maybe the mirror is really high quality, right? So you can't see the mirrored surface, and you might be completely fooled that there's even a mirror there. That's the whole point of some of those things at carnivals and so on, you know, spooky ghost houses and stuff like that. They all play with mirrors that are really high quality, and you can't tell sometimes if you're looking in a mirror or not. Alright, so what does that mean? Basically, when you see an image in a mirror, what you see appears to be behind the mirror. Alright, so the image is going to look like it is somewhere behind the mirror. Of course, it's not actually behind the mirror, but again, if the mirror is pretty high quality, then it's going to look like you're looking into a window almost, not into a mirror. Right? You can even find where the image is behind the mirror. Alright, so that's the last bit of this video is going to be talking about how you do that. Okay, so how do you find this image behind a mirror? Well, there's several steps. First step is that you draw a ray of light, which is just going to be basically a straight line with an arrow on it, from the object, some point on the object. Pick a point that makes sense to you, maybe the tip of the object or maybe some other distinguishing point on the object, and then it's going to strike the mirrored surface and reflect. Now, if you're drawing this on paper, you're going to need to use a protractor. You're going to need to be very careful with your angles and draw straight lines with rulers and so on, just so you can figure everything out. Right. Then you're going to draw at least one more ray. You got to start from the same spot on the object, but you're going to hit at a different angle on the mirror. So you're going to strike a different point on the mirror than the first one. Alright, but it will also strike and it will also reflect. So you've got this incident ray that is reflecting off the mirror, but a different point on the mirror than the first one. So then you would have to figure out the angles for that and everything, the angle of incidence, the angle of reflection, be very precise. And then you're going to take both of those rays and trace them backwards in a straight line. Alright, so you're going to trace the reflected rays backwards in a straight line till they go behind the mirror, and we'll see what that looks like in an image here, in a diagram on the next slide. Okay, so those are the first three steps. Draw one ray, draw at least one more ray, and then you're going to trace them backwards to the point where they meet behind the mirror, and it will look like this. So basically this is what you've got going on here. Alright, so you've got some object at this point right here. That's the object somewhere in there. And that's a point on the object. You can see that all of these rays originate from the same exact point, but they're all different angles. So they all strike the mirrored surface at different spots. And they're all obeying the rule of reflection, which is that the angle of incidence equals the angle of reflection. So then what you do is you take one of these rays and you trace it back in a straight line. Obviously mine's not straight, but you trace it backwards until just a ways back. And then same thing with these other ones. I'm not going to draw them in, but same thing with these, right? Trace them back, trace them back, trace them back. It's often a good idea to draw the dotted line when you're going behind the mirror, just to show that there's not actually light rays back there. They're virtual. We'll talk about that in a minute. So you trace all these back, and you'll notice they all go to the same spot. So this point right here, this point, bam, that point right there. That's the point where the image appears to be behind the mirror. All right, the image is going to be right there of whatever it is. So I don't even know what this thing is, but it's not drawn in. But in any case, that's what it would look like. This is where the image would be, behind the mirror. Okay? And if things are really clever and tricky, you won't even be able to tell that it's behind a mirror. Alright, so the image is there at A prime, and that's where the object appears to be, though of course the object is not actually there at A prime. The object is actually there at A. There's actually nothing here. I mean, well, there is probably something behind the mirror, but it's not going to be something that you could see like that. Alright? Okay, so what are some features of this image? Well, there are four main things that are true about an image that forms behind a mirror or in a mirrored surface. First, for the image, right, this is for the image, not the object that is producing the reflection, but the image. The image is virtual, and what that means is that there's no actual light rays passing through the location where the image appears to be, right? The image appears to be behind the mirror, but we know that usually mirrors are like on the wall. You don't see behind what's behind the mirror. That's not what you're seeing. What you're seeing is something that's in front of the mirror that looks like it's behind the mirror. So there's no actual light rays passing through the location where the image forms. All right, there is no light rays there that you can see. All right, so it's a virtual image. There's not actually an image. Another way you could think of it there is that you can't project this image onto a screen. It's not something that you could put there and everybody could look at it, right? A screen behind the mirror and you'd see the image. No, you wouldn't see anything if you put a screen behind the mirror. So that is why it's virtual. It's not real. There's no light rays actually passing through that point. The image is upright. It is not inverted, so it's straight up and down, right? It hasn't been flipped vertically. It's still upright, right? This image, this represents, down here you can look at this. This is the front of a fire engine in the US, and one side this fire is spelled correctly, and on the other side it's spelled the way it would look in a mirror. And why is that? If I look in my rear view mirror, I will see this one as being like basically readable correctly, and this one is the one that will appear flipped backwards. All right, because that's what mirrors do. You could imagine there's a mirror right here, and this is what the reflection would look like. All right, so it's flipped horizontally, right? Not vertically. So the F is still vertical, right? But it's backwards horizontally. It's the same size, right? Both the same size, same size, same size. They are not changed. The size is not changed by reflection. The image is going to be the same size as the object. All right, and it's flipped horizontally, which we already mentioned. So basically, if you could imagine that this is like a board or something that you could grab it and flip it around horizontally, then that's what happens. Okay? Cool. That's the main ideas for reflection, and hopefully that's clear and understandable. And we'll talk more and work with that more in class. Thanks for watching.